So hello everyone, welcome back to Advent of Code, to our final day of year 2025, day 12. Um, we're going in completely blind. I don't know what to expect honestly. It could probably be extremely easy or extremely difficult. Usually the problems are easy. It's for the last task, but I don't know. Only way to find out is actually to enter the task. So let's do it. Day 12, Christmas Tree Farm. You're almost out of time, but there can't be much left to decorate. Although there are no stairs, elevators, escalators, tunnels, chutes, teleporters, firepoles, or conduits here that would take you deeper into the North Pole base, there is a ventilation duct. You jump in. After bumping around for a few minutes, you emerge into a large, well lit cavern full of Christmas trees. There are a few elves here frantically decorating before the deadline. They think they'll be able to finish most of the work, but the one thing they're worried about is the presents for all the young elves that live here at the North Pole. It's an ancient tradition to put the presents under the trees, but the elves are worried they won't fit. The presents come in a few standard but very weird shapes. The shapes and regions into which they need to fit are all measured in standard units. To be aesthetically pleasing, the presents need to be placed into the regions in a way that follows a standardized two-dimensional unit grid. You also can stack presents. As always, the elves have a summary of the situation your puzzle input for you. First, it contains a list of the presents shapes. Second, it contains the size of the region under each tree and a list of the number of presents of each shape that need to fit into that region. For example, okay, I will assume these are the shapes. I don't know what are these like indexes of each shape, and these are those regions. The first section lists the standard present shapes. For convenience, each shape starts with its index and a colon. Then the shape is displayed visually, where hashtag is a part of the shape and dot is not. The second section lists the regions under the trees. Each line starts with the width and length of the region. 12 by 5 means the region is 12 units wide and 5 units long. The rest of the line describes the presents that need to fit into that region by listing the quantity of each shape of present. 101032 means you need to fit one present with shape index 0. Okay, so I guess that's why we have these indexes to like know. So this is zero based. So like present with index 0 goes once, present with index 1 goes 0 times, present with index 3 goes 1 times, with 2 with 3 0, 4 3, and 5 2. Presents can be rotated and flipped as necessary to make them fit into the available space, but they have to always be placed perfectly on the grid. Okay. The first region is 4x4. In it, you need to determine whether you could fit two presents that have shape index 4 after some experimentation. Two presents that have the shape index 4. After some experimentation, it turns out that you can fit both presents in this region. Here is the one way to do it. Second region, still units wide and 5 units long. In that region, you need to try to fit. So in this example, two regions can fit all of their listed presents. Uh-oh. Okay, so the first thought that came to my mind is a Advent of Code Jurassic Jigsaw. Jurassic Jigsaw, I believe it's this one. Yeah, where they can be rotated and flipped to a random orientation, and we need to basically get them to match. That's what they're asking for us. In this case, they can overlap with each other, which makes it much more difficult. Oh boy. Uh, this is a part of this problem is a part of a algorithm called recursive backtracking, which I absolutely have no idea how to implement. I know about it, but wouldn't know how to even begin. Although there is one assumption that I will make, since we need to just see if the presents can fit. Maybe, just maybe, our grid is large enough to fit the presents from our input. And that would be like some sort of extremely naive approach. But maybe it will work, maybe it won't. I have no idea. Only one way is to try. So I guess we can start doing that. Also, a part of the problem is to kind of figure out how to parse the input, but that shouldn't be that difficult. We'll see though. I'll close the other previous days. I'm gonna create day 12, day 12.py, input.txt, and input example txt. Let me just get the, how do we call it, my example input, although I believe I won't be able to do much with it. And I will just get my main input. Okay, everything should be here. How to now parse this in a better way? So I need to be checking if there's an empty line, then that isn't valid. I guess here we can, for these ones, we can check if it has like X and a colon and it doesn't end with a double colon, then I guess it's like a region we can accept. I guess I can store the shapes as like in a dictionary, like index 0 and then this, like shape. And this I can store inside an array where we will have like sizes and the given amounts of gifts. So I guess we can do that. I'll start by writing shapes equals this, dimensions equals this, with open example as f. Okay, let me just adjust the spacing. Is there something I want to keep track of else? Since we'll be reading line by line, I guess I also need to keep track of like when we reach the empty space, maybe like a buffer of some sorts. I guess I can do like buffer will be empty array. And then when we are done parsing, like until we stumble upon one of these again, then we just know we can append the buffer to our shapes or however else it should go. Line in F, we will just do stripped line equals line.strip so we don't bloat anything else. So we can immediately check like if our line is false, if strip line is false because we strip it of everything, then we can just continue. So if stripped line, we continue. And I guess we can start off with the simple ones, which is gonna be these regions. So we will do if we have in our stripped line and we have a colon in our stripped line, but, oh my god, and we don't have it at the end of the line because ends with is in Python. Interesting, I forgot about that. Because we want to make sure that we aren't parsing this this. I believe this should be enough. No, because this would be, and this would then just fail. Okay, yeah, no. We'll get size and amount, which is gonna be a strip line dot split on the. Does it contain space at the end? Yeah, it does. And dimensions, I guess I can call it regions. Yeah, they're called regions. Regions equals not, we need to append, and we will append a size. I guess we can split it. I don't think I write that like the dictionary keys like that, so I guess I'll do it like this, and then list of a map to integer of our size dot split by x and amount of gifts. We just do the same thing. We just do the same thing basically of amount. Amounts. Split on nothing because they're separated by spaces. Okay, I guess that should be it for this. And then once we're done with that, we continue. And now, if our stripped line ends with the double colon, and I need to somehow keep the track of the ID. So I guess I can do current ID. We can initialize it with none. If our current ID is not none, then we can append our shapes to the current ID, where we can then just append our buffer. Would it be like that? Oh, no, like this. Yeah, it just becomes our buffer. Yeah, our buffer, because it will be just filling it up. And then I can do, I guess, current ID will equal to the integer of the strip line. And we will get the number without the colon. And we reset our buffer to an empty array. Else we can append to our buffer, we append our strip line, because then that would mean this gets appended as its own line. And we need to make sure that if we reach the end and our current ID is not none again, and our buffer actually is still full, we can do shapes of current ID equals the buffer. Would that work? Let's check print shapes. Am I getting it from example? Okay, that seems to be correct. Yeah, let's check for the input 5. 5, and it goes. Oh no, something is not good. I'm not resetting my buffer somewhere where I need to. Why is that? Where am I supposed to reset the buffer? It should be here, right? No? Because we create a empty buffer if it ends, and we get a current ID and a buffer, and then why are they the same though? Oh no, the way they do have differences. Okay, I'm just being crazy for some reason. I was checking my input and I got really confused. Okay, and let's check regions. Size 4, 12, 5, and 12, 5 again. Oh damn, these two regions are the same, they only have different this digit. Okay, so that seems to be good. Okay, now I said that what I want to do is to check if the areas would fit. Like if the areas of the shapes, like if we would go together, because we have this region and we need to like check if for the 1, 2, 3, 4, 5 fifth gift, this one, if we can actually fit two of them. So the area would be since it actually seems that all of them are like 3 by 3, so here the area would be 9 minus 2 empty spaces, which is 7. 4 by 4 is 16, and 7 times 2 is gonna be 14, so that would fit immediately. Wait, what? That kind of makes sense. Yeah, I guess we can do that as a check first, and like if it fails, we would then need to figure out if there exists how we can write our algorithm. So okay, I guess I can begin with the code. The question is, should I immediately get the size of the area or not? Let me just check how our shapes looks like again. Looks like this. Okay. Okay, I see. Okay, no, I'm just gonna leave the shapes as they are, because we'll probably need them for later. So we'll do a write function, check if region, check if gifts fit the region, and we'll just pass in the shapes and our regions. Once we have that, we'll just like write fit in regions is gonna be 0. Now we need to, I guess, go through all of our regions, region in regions, and then we can get our size, which is gonna be a region of the size, since we're now accessing the region size, and then we get our amounts, which is gonna be a region of amounts. Once we have that, we need to calculate first the area of our region, which is going to be area of region equals size of 1 times size of 0 times size of 1. And we will be going through all of the amounts and like calculating for all the shapes individually. What's the area? I guess we also need like a total shapes area, which is gonna be equal to 0. And for index, comma, amount in enumerate amounts, we'll get our shape from shapes with the key I, in this case index, because they're 0, it starts 0 based. Once we have that, we get our shape, and since we want to get the areas, we need to calculate how many hashtags we have for each individual one of these. So what I can do is, would it be like shape area equals a sum of, how would I guess like part of shape dot count hashtags for part of shape in shape. So since our shape is like of, let me just like show. since our shape is like gonna be like this, and that, we can just use the count, and the sum would get the size needed. Where is it now? Oops, here, the shape area. So we just sum it up. And then what we do is total shapes area will equal to a sum of the total shapes area plus the shape area times the amount itself. And I guess that should be it for that. And we just check if the area of region is bigger or equal than the total shapes area. We do fitting regions. Oh, fitting regions plus equals 1. And I guess we can then return the fitting regions. Print, so fitting regions will equal to the check if gives fit. We pass in the shapes and regions like that, and we, I guess, just do part 1 of part 1 fitting regions. Oh, not print. Okay. We get 3, which is obviously the incorrect answer because they have 2 here. What will happen if I run it on my own input? 512 doesn't seem like a correct answer. We don't know. We'll check. Let me just switch to the Advent of Code window. Why is it not working? Okay, now it should be fine. Well, that's the right answer. Wow, okay. Wow, that's a relief. Holy, that's a relief. Okay, Dame, I didn't know that would actually work. That's such a scam and a troll from the developer. So, okay, to quickly explain what we have done. So I did a naive approach. First, I checked if all the shapes for each individual region can fit inside of it by sort of like placing them next to each other, if we can put it that way. And what we then just do is we just check if our area of region is equal or bigger than all the shapes that have been placed inside that region, then it fits, otherwise it doesn't. And I'm so glad this works because I don't think I have the capacity or the time to learn about recursive backtracking. But I would like to revisit it at some point in the future because it would definitely be a fun learning experience. So yeah, let's continue with our part 2. The elves thank you profusely for the help and start rearranging the oddly shaped presents. As you look up, you notice that a lot more elves have arrived here at the Christmas tree farm. In fact, many of these new arrivals look familiar. They're the elves you helped while decorating the North Pole base. Right on schedule, each group seems to have brought a star to put atop of one of the Christmas trees. Before any of them can find a ladder, a particularly large Christmas tree suddenly flashes brightly when a large star magically appears above it. As your eyes readjust, you think you notice a portly man with a white beard disappear into the crowd. You go look for a ladder, only 23 more stars to go. You have enough stars to finish decorating the North Pole. You help the elves decorate the Christmas trees with all 24 stars. Now the elves will have plenty of time to prepare for Christmas, and you get a well-deserved break. Congratulations, you finished every puzzle in Advent of Code 2025. Dame. Okay, how does it look like? Ah, that's so cool. Look at it go. Okay, so final thoughts. Extremely fun year. I'm glad that tasks weren't that difficult, except for me it was like days 8, 9, and 10. 10 being an absolute monster. Wait, was it a 10? Oh no, it was the day 9. Yeah, day 9 being an absolute monstrosity. But yeah, we managed to do it. We got it, and that's basically it. I hope you guys have enjoyed this journey alongside. Have enjoyed this journey in general. Hope you guys have also learned something, and I don't know what to say. Hope you guys will have a fun holidays. Hope you guys also manage to solve everything yourself. And until next year, enjoy, have fun, be safe, and peace. And I guess for a small part 2, we can add like part 2. I don't need to format string, just like Merry Christmas, the smiley, and if we run it, we will get Merry Christmas